There's dominoes everywhere, right? Like I'm sure every place where we are living, dominoes should be there, right? Or is it just a Indian thing?
Oh, Domino's is everywhere.
Kojak said something, but I'm not quite sure what he said. I think he commented on Domino's pizza in India. No, I don't know. I don't even know if we have Domino's pizza in.
But this image is in dollars, so I'm sure like at least it's there in the US.
Well, we will just believe you. It's
Yeah.
gonna be fine.
Yeah. Okay, so do we want to start? Okay, but
Wait.
we have two new people.
Okay.
I mean, they were not there in the last session.
Take a breather. Okay.
Mm-hmm.
Let's give it like 1 more minute. Okay.
Right. No, but I was thinking at least we understand. Calebos wasn't there, right? Last time too, and Crypto Keeper wasn't there. I think
so too. But maybe let's give a quick wrap of what's going to happen today, right? Okay.
Yeah.
So last time, Roro was so kind as to introducing us to some core principles of coding in Python, which he's right now showing on the screen, right? There were like comments, variables, basic data types like strings, integers, and floats, logical statements, predefined functions, such as, for example, print, lists, dictionaries, functions, conditional statements, loops, and importing files. And I think we're going to go today deeper into importing files, loops, and specifically functions and conditional statements. Yeah.
Are we? Yeah, I mean, kind of. I think we are deeply going into functions. I don't think I'm introducing loops yet. Because pretty we could. But we'll see how the vibe is, because I think functions themselves are pretty pretty hard to grasp. What I actually wanted to do was go through a much so this is the example we're gonna do, and I wanted to put this as an exercise, which is much more complicated. But I think we should be able to model a system like this as a homework exercise, maybe. But yeah, Crypto Keeper, can you maybe unmute if possible, and tell us if you have some basic idea about Python, so then I can plan my comments accordingly.
Yeah. Cool. Yeah, I have a basic understanding of Python. I've been going over it. Just the basics. How to use floats, integers, and just the basic stuff so far. But yeah, I haven't gotten really deep into it, but I do have a basic understanding.
No, that's perfect. That's more than what most people have here. So we'll be good. And Calebos, if you can unmute.
I'm not really into coding.
Okay.
I have experience with it.
Okay, I'll do one thing. I'll just go through whatever we did in the last session, like a little bit, so you get an idea about how we are thinking about it. My main goal throughout all of this is to just hammer it in everybody's head that it's not important to remember the syntax about how to write code, about how to do things, because you can always just go to some website like W3 Schools and just copy paste that code and just play around with it. The main goal that we have here is to understand what all functionality Python has. How can we use it to build data structures and things that we need in order to model our systems, so that module 4 becomes something you can just, at least go through. Like when you're looking at it, you'll be able to understand why we use dictionaries, what are dictionaries, why we use functions in different places. And I think by the end of this lecture, I want to be able to, if we have a diagram like this, like for example, or even like this, right? Like there's a farm, the farm grows fruits, farmers buy those fruits, they sell it to these shops, some of them rot, and some of them get sold to people who want to buy. It's a simple system, just many stakeholders. But what I want to do is like, when the way we went through module 2 and 3, we understood how to think of a system in terms of stakeholders, agents, roles, actions, and then like system goals, system requirements, and then stakeholders, agents, actions, roles, and using those to build our token systems, or think of our token systems. I want I want the ability, I want us to have the ability to build a chart like this, which is basically like a stock and flow diagram in some sense, and from here know how to convert it to Python, or at least know what element will be used where, like functions will be used where, data dictionaries will be used where, etc. So let's start off with just a brief a recap of what we did last time. We understood what comments, variables, and data types are. So comments are basically just some code that Python won't read. It's for us to talk to each other when we are or explain our code to each other. You have data types like numbers. You have basically strings. Numbers can be of like a couple of types. Like numbers can be an integer. You can have a float. Float is basically a decimal number. And you have these predefined functions that Python gives us, which is something like print or type. We can use type to find out the data type of the variable that we've defined. Variables, again, just as a reminder, variables are just holders of data. Like they are just, we think of them as containers. Like I defined a variable here, I gave it the value of 2. Now the value of 2 is defined as this thing. So whenever I write this thing, 2 is what it will print or be used for calculations or something like that. Then we move on to lists. Lists are the first relatively complex data structure we go into, which is basically just a series of items. These items could be of different types. Like you have strings, you have you have floats, you have integers, you have booleans like true and false, and you can have strings too. We can print those lists, and they will be. Not sure if I mentioned here, but the Collab docs are very helpful. Oh, thank you. Right, so we can define these lists. Lists are ordered. It's an ordered list of items. So we can actually call them like this. So if we define a list, a variable called fruits, which holds a list, and when we run the code, if I call the list again and I add a square brackets with a 0 in it, it will call out the first function. It'll link to the first function. I don't know what's the right word. But yeah, like if I want to go for the second and the third, I'll go for 1 and 2. So let's start count. In computer science, generally we start counting with a 0. So we go from 0, 1, 2. And 0 will be associated with this, 1 with this, 2 with this. All of these things will be required, and the reason I'm taking some time here is because when we get to the actual meat of modeling things, this should be something that is relatively fluent to us. Like we should be able to look at it and understand, oh, this is a list, this is a dictionary, these are things that are happening. We have a dictionary here. Dictionaries are a different kind of data structure. It's kind of like lists, but instead of having 0, 1, 2 associated with the first, second, or third data type, you label the data types itself, like the data itself. So apple is red, banana is yellow, kiwi is brown. Generally, there's a key value pair, which is what defines a dictionary. And usually the way I think about it, at least, is I use dictionaries when there are certain properties of a system I want, like which we can see here. Like for example, if I want to build a dictionary of a fruit, like our data about fruits, so we can have apple as the key and then add properties within it, which is like the color of the apple and the number of apples that are there. And same with and then we can add more fruits. But the point is that we can use dictionaries to define data which is labeled, and we can use those labels to call the data within. So it's like, again, key value pairs. And we can have, this is a nested dictionary, by the way. So this is a dictionary which is within a dictionary out here. If you want to go through a nested dictionary. Yeah.
Can I bring my favorite example for a dictionary and a dictionary?
Yeah, sure.
The babushka dolls. I'm putting a GIF in the chat.
All right. Wait, can I run? Okay, I think these will still run. Also, by the way, anytime you are on a code cell, this is a Jupyter notebook. So anytime you are on a code cell, you can type Shift and Enter, and it reruns the code cell. So you don't need to click on these. I usually just do Shift Enter to run all of them. But the point is a nested dictionary you can use, just like the lists, we have those square brackets, but instead of 0, 1, 2, we call Apple. So whatever data is within Apple will come out of this. And if I go for Apple and number, I get the data which is within the second nested dictionary. I hope this is clear so far. If anyone has an issue, please pause us right now. Basically, the reason we went through all of this is to understand why in module 4, when we just open the first page of module 4, you'll see within the first few lines, this is the code cell that you'll see, which defines a Genesis block. And that has the AMM, that has the trader, and that has the liquidity provider. And R1, R2, S, and fees are defining the current state of the AMM. R1 is the supply of token 1, R2 is supply of token 2. But again, it doesn't matter to us right now. The point is that if you understood this, which is you build a fruit dictionary, you have keys called fruits, and you have their properties inside them. That's pretty much what this is. And we've understood how to define a state of a system. And you'll be able to read this much more fluently when you open module 4. Another huge piece of the puzzle which we couldn't really properly go into were functions. Now, functions are a Python primitive again, and they the way you think about them, it's a block of code which only runs when you call it. So here I'm just defining the block of code, and the block of code will be called my hello function. And when I print it, it prints hello. So what happens is the second, in order to define it, you start with this thing called define. You label and you name it whatever you want, just like a variable, but you add these curly brackets next to them. Curly brackets, right? I don't know. No, wait, curly brackets are those. What are these? Maybe, I don't know. Maybe they're curly brackets.
No, this is just round bracket.
Round brackets, yeah. Round brackets. And so whatever code was here got printed when I executed it. The reason, a very valid question is why do this at all? The reason we do that is because one reason is sometimes there's a particular line of code or like a code block which you want to keep on referring to again and again, but maybe only one thing changes in it. Like, for example, if I want to greet someone, I don't want to keep on saying hello. So one way to do it is I define my greeting function. You can name it whatever. I pass an argument into that function, and we can use that argument to do things within that code block. The argument itself, you need not define it when you're defining the function. But when I'm calling the function, I can pass that argument here. So when I call it with hi gets defined as greeting, and greeting is printed out. So now instead of printing the same thing again and again, I can actually use different strings to be printed out. It still seems kind of silly. Why would we do this at all? I'll give you an example here. So basically, let's say this is something we want to do. Like we want to eat pizza. and we go to Domino's and we see this chart where it tells us that, okay, the pizza's diameter is this size, and the price is 9.99. The medium size is 14 inches, let's say, and price is 15.49, and then large is 18, and the price is 17.9. Now, I don't know which pizza is worth buying. Ideally, what I want to do is I want to buy the most pizza for my money. So the way we can go about it is we can construct a function, because if you want to do this for every single piece, these are only 3, but there could be a list of like 100 pizzas, and I need to do this same thing again and again, which is take the diameter, find the area of the pizza, and then divide that area with the price. So then you find out how much pizza are you actually eating for $1 that you're paying. So what the way I went about solving it is I first copied all of the data here. So we have small pizza's diameter, medium pizza's diameter, large pizza diameter, just 10, 14, 18. That's just right from here. And we have small, medium, and large prices, which again, I just straight copied from the chart. Now I defined a function which finds the area of the pizza for me. So what I do is I define a function which is called area of pizza. I pass an argument called diameter, which I have not defined yet. Diameter will be the radius will be diameter by 2, and area will be pi r square. So I take the radius, I multiply it by pi and square the radius out here, and that is my area. And I return this area. So what basically is happening here is, if I call this function area of pizza with 2, 2 goes into the diameter, gets divided by 2 to find the radius, which is 1. And when we do area is equal to pi r square, which is 1, what we get out is pi, and what gets printed is pi. So basically, instead of writing this function again and again and again for every single variable, what we end up doing is just writing it once, this code block, and then just calling it using the name of the code. Is it clear so far? Am I going too fast?
What is return? Is that another function?
Oh, okay. Sorry, yeah, I didn't go through this. Functions have a predefined like final statement called return. So it ends up, so for example, if I do this area, or whatever, like, I can put in function x, and I can say area of pizza and 10. What this will do is x will become 10. So whatever I return, not 10, but like area of pizza 10. So whatever the answer would be. But the point is that
is this a predefined word within Python? Return?
Correct. It's a predefined word within, especially within functions. So what we were doing here, right, was printing it. But a lot of times you don't want to print it on the screen. You want to use it somewhere else. Like you don't need it to constantly keep on showing on your screen. So what we can do is, instead of printing it, we return the area. So whenever I call this, whatever gets returned is what will be assigned to the variable that I choose. And in case I don't assign it and just print it, it just prints it. So basically, this just became x, and x is what we printed here. Is that clear?
Yeah, thank you.
Yeah. So, the main point is that you don't need to, because here we are just printing things constantly so that we can see it on the screen and understand what's happening. But when you're actually writing like code, you don't need to print it every time. You just print it to see, to maybe debug or to check things that, like what the value of something is at certain points. But ideally, you want to assign it to something and then use it somewhere else. Because I don't care about I don't want it to print every size of the pizza when I have millions of pizzas that I'm going through with my code, maybe.
Roro, can I ask you something else?
Yeah.
above where you define area, right?
Yeah.
It says R and then to the power times 2, or what
Yeah.
is that? Why is this little star there twice? Is this like the double equal sign?
No. It's so like if I do 2 raised to 3, this should be 8, right? 2 into 2 into 2 is 8. So this is just a way of saying raised to 3, like this R square. It's like square. When I do it with 2, it's squaring. When I do it with 3, it's cubing.
So it's like 2 to the power 3, 2 to the, and then if you had 4, it'd be 2 to the power 4.
I could have just written it like this. This also would work. R into R is R square. So I could have done it this way, but we can also just use exponentials. It's a way to basically do exponentials. Is it confusing still?
Stella, I think maybe just an easy way to put it right. Let's say if it is 2 cube, so instead of doing 2 into 2 into 2 3 times, it's an easy way of representing it. That's it.
Correct. Yeah.
Okay, got you.
Right. Yeah. So if I want to do it 4 times, yeah, I would do this. But I mean, it's just squaring it, and I'm just multiplying R twice. That's it. Okay. So basically, what we did so far, I'll just recap. We took this chart. We took the small, medium, large sizes and prices. We put them as variables just so that it's easy. It's clear what we're doing. I defined a function with that takes in the diameter and gives us the area back. Right? That's all we care about. This part doesn't matter how we computed it now. As long as we are getting the right answer, that's done. So we defined a function that gives us it takes the diameter, gives us the area. Now, in order to find how much value the pizza is to me, I have to find the area of the pizza and divide it by how much I paid for it, right? That tells me how much value for money the pizza is. So I define a function called value for money, where I take the diameter and the price, which is what we had in the beginning. I find the area of the pizza using the area function that we defined. I take the ratio of it of the area and the price, and I return the ratio. So what ends up happening is that whenever I use this function value for money, and I pass in a diameter and a price, I'll basically get this ratio, which is area by price, like how much pizza per dollar am I getting. And what we find out is when I use it on small pizza, like the small pizza diameter and small pizza price is when I pass, I get 7.8. For medium, I get 9.9, and for large, I get 14.3. So 13. So that means that per dollar, I get 14.13 inch square of pizza, basically. If that makes sense. Basically, if the number is bigger, I'm getting more pizza per dollar. Is the point. So again, the reason we do it this way, like I'll go through it again just so that it's clear, is that if I had to do it for like 100 of these pizzas, right? I wouldn't even do it this way. I wouldn't define every single thing as a variable. I would write a loop and it just goes through the entire data set and computes this for me and ends up giving me the final value. But what ends up happening is like instead of writing like these lines or 5 lines of code out here, if there were like 10 steps in the middle, I could have just made a function for every step and just written it this way. It's so much easier to read this than it would have been to read all of the code of how to find area, how to take the ratio, and then print it out, and then assign it to the value. Again, if I'm speeding through it, please stop me. But the point is that functions are really, really important, and what we're gonna do with them is what they allow us to do is build a black box, right? It's a box where there's a bunch of code. I don't care what that code is anymore. Like I wrote it when I wrote it. Now I don't have to look at it. I just know that if I put in diameter and price, I end up getting the ratio that I want. In this case, in the case of area, if I just give diameter, I end up getting the area of the circle. And what that helps me with is, it helps me abstract huge sets of code and I don't need to rewrite it again and again. I can just use it once or twice. Now, if this is clear, if it's understood that functions are basically black boxes where we put in a bunch of code, we don't want to look at it again. We solved it once, we wrote it somewhere, and now all I need to know is the inputs and the outputs, and that'll give me the area if I want area, value for money if I want value for money. And the main point is also that you can use functions within other functions, which is what I did here. Like I wrote an area function and I used that to find the area of this pizza that I'm calling here. Again, are we like, is it too fast? Am I clear? Can I just get like thumbs up if things are fine? Yeah.
Yeah, I do have a question, Roro.
Yeah.
When you're defining that function, you go to the value of money, the value for money. I see the diameter there and the price. So are you defining both of those below?
Yeah, here. So, okay. Wait, let me just do it this way. Since we had defined this earlier, right? We had defined small pizza diameter as here. That's what I've done earlier. So I can just do it this way. Like basically what I need is I need to call value for money. And we can look at another pizza. I have this open. So there's a 12-inch pizza, which is 13.99, right? So I can just put in the diameter first, which is 12-inch and 13.99. That's all I need to do. I need to call value for money, pass in the first diameter and then the price. And that's what I defined it, right? Diameter and price. And if I run this, we get whatever the value from money was, which is 8 in this case. So still the large pizza is the best for it. Yeah. So the reason I didn't the reason I didn't have to define these variables here is because I'd predefined them earlier. And you can, if I just hover over the variable, it shows me that it was defined earlier. But okay, like regardless, like don't worry too much of the syntax. It doesn't matter what you pass here, what you just have to remember the concept, which is function is a black box. You give inputs, you get outputs, and you do a bunch of computation in the middle. That's all you have to remember from this. And for dictionaries, it's a way to store data. For lists are a way to store data. The differences between them are list is just a series of whatever items you want to put into one list, and like maybe think of it as one category or however you choose to use it. But for dictionaries, it's a way to be more descriptive when you're saving the data, or show hierarchy. Like if you look at, we can do it here. Okay, see. List is just a dictionary is just a more descriptive way to say that, hey, the store has apples, bananas, and money. Customer has apples, bananas, and money. And how many of them do they have? So it's a descriptive way to store data. Okay, so this is, I'm going to walk you through a very simple concept of a fruit store. Like if we, and this is like maybe one step between what we learned and understanding how to code AMMs eventually. The way I think about this stuff is, in order to understand the problem first let's define what we want from the fruit store. So the way I thought about it, yeah.
Before you go into the exercise, right? Can we just get like a vote on the side chat from everyone, where they are at, in which module, just to be aware, like where everyone in the session right now is at. So I put a little like voting block into the side chat, right? Stating like you essentially just need to click the little emoji underneath for the module you're in right now. And I see some of you have already put the little circles, right? So maybe let's make it all, and also specifically Kaleverse, because I know you missed some sessions, where you're at and how you're feeling about all of this. Is this like way over your head, or do you feel you can catch up to this? Kind of important to know, I think, at this stage.
Although, I mean, the Python section is pretty standalone regardless, so far.
Yeah, so far, but it's maybe also good to mention that Collabs, if you're intending on completing the modules, right? We're doing this, or Rohan specifically is doing this for us, because in module 4, like, you're just being hit with code sections that you might not have a clue what they mean. And one very important part of this is functions, or also nested functions, right? And this is why he's kind of like putting this in the focus of this session. I think that should just be said. Okay, did you all vote? Did you vote?
3, it seems.
Did everyone vote? And also get Kojak, get the yellow circle out of there. The yellow is the orange. the circles, right? I'm actually so dumb I put circles in colors, because maybe some of you have a sensibility to different colors or not, right? But I also put them in the right order. So you just have to count down, essentially, right? So module 4 would be the 4 circle emoji to click. Okay, please go on. I guess if no one wants to say something, let's go on. And also, I think Collabs just left. Shit. Okay, sorry.
He's scared of, yeah. Okay, so the way I'm trying to go through this exercise is, I give a very simple problem. A situation, and this situation can be modeled. And we use some of the concepts we learned earlier to actually convert this conceptual idea that we have about a fruit store to something that we can represent on Python, define a state of the system, update that state using certain actions which agents can perform. The way we can think about this is, the fruit store is this, that there are 2 fruits, apples and bananas. There are 3 roles. I'm still a little confused about agents and roles, but I think these are roles. Like there could be more agents. I don't know, whatever. There's 3 roles here. There's a store, there's a customer, and there's a farmer. Okay. Each of the 3 roles can own apple, bananas, and money. Not all money, but and money. They do all 3 at the same time. And a snapshot of the amount of items held by each agent can be defined as our state. So so basically our state, it could be worth going into what a state is. A state is basically just, if I were to pause the system right now, like on day 2, day 3 or whatever, I want to know how much money does the farmer have? How much money does the money, apples and bananas? Where are the things that I care about in the system currently? The snapshot of that, all that data together, will be called the state, and the state will define everything we want to know about the system currently. So we have 3 roles. Their ownership of the assets, like apple, banana, money, at every point of time will be the state. Each of the 3 roles can own apple, banana, and money. A snapshot of it is our state, and the customer can buy fruits from the store. Now, these are the actions that we are defining, right? The actions that these agents can perform, or the roles can perform, is the customer can only buy from the store and give money to the store. The farmer can sell fruits to the store and buy and get cash back, if that makes sense. So they're doing these trades, but they can only do it with the store. They can't do it with each other. So that's the system that we're trying to define. Again, as we understood, that in order to understand to get the state right, all we need to define is store, customer, and farmer. and how much of what they have right now. So like the store currently, I started off with 50 apples, 50 bananas, and $200. But the customer has 0 apples, 0 bananas in the initial state, right? 0 apples, 0 bananas, and $200 of cash. Farmer has 100 apples, 0 bananas, and $10 of cash. We could have defined anything. We are starting off with a random number. So when we print this, we can see that, okay, whenever I print fruit data at any point of time, right, I'll get all the information I need about the system right now. And this is where the first action we are trying to now state. We are trying to model in our system. We have data, like we have the state. We need to update the state every time some action happens. Because if a customer buys, let's say, fruits from the store, what will end up happening is I want the fruit that they bought to reduce for the store, and the fruit for the customer to increase. I want the money for the store to increase and money for the customer to decrease. Does that make sense? Because the customer will use money to buy fruits. In order to define that on Python, we want to convert the conceptual idea into an actual, something that actually changes the state. The way we do that is actually through functions. And this is basically the stuff that will go inside a function. I'm just trying to... this is how I go about my coding. I wouldn't just make a function from scratch. I would first actually try it out. So I would first write, let's say the price of apple is $2. The amount that the customer wants to buy is 20. So I'm just randomly defining things to see whether my code will perform the way it wants it should, and then I'll put it into a function. So I take the fruit data, which is a next nested dictionary. I go inside the farmer. I go inside the apples of the farmer, and I subtract an amount, the amount of apples that we want to subtract. Let me just briefly explain this. So let's say x is equal to 5. Okay, that's the variable that we have defined. We can do x is equal to, if I do x is equal to x plus 5, which is a statement you can make when you're coding in Python. And now if I print x, what do you think the x will be, Stella? The quiz on you.
10.
Yeah, perfect. So x was 5, we added 5 to the previous x, and that defined the new x, and that's what we are printing. This, to anyone who's done math, this looks pretty ridiculous, because how is x equal to x plus 5? Because the thing is, equal to sign in coding does not mean equals to, it means a sign. So the way you read this is, I assign the value of x plus 5 to x. And what was x? Which was 5. So this x will basically look like 5 to the code. It'll add another 5 to it, and it'll print out 10. Just remember that x is not equals to, it's a sign. Yeah, so what I'm trying to do is, another way to do the same thing is I remove all of this, and I just add a plus here. So x is equal to 5. And when I say x plus equals to 5, it basically means is whatever x was before, I want to add 5 to it. And I want to redefine it as. So it'll be the same statement. If I rerun this, it'll do the exact same. Yeah. If that's clear, then we can basically show what's happening here.
Pardon me, Rohan. I have a quick question. If you put equal there, I would and you would immediately define the value of x, right? Is that syntax correct?
No. So when you do equal to, what equal to means is, so this will actually give you a Boolean which will say true.
Okay,
so,
got it. Okay. So I'm mixing up my syntax then. Okay.
Yeah. So what this does is just says that is x, this is actually equals to, like it's checking, is x equal to 5, true or false?
Right. So if this was, say, for example, is equal to 10, that would come back as false.
Correct. Yeah.
Right. Okay. I mixed up my I have too much in my head. Okay, that's good. Thank you.
That's okay. All we need to know is this, that when I do plus equals to, all I'm doing is adding the amount to whatever the variable here is, right? So again, don't overthink this. All we're doing is adding amount and subtracting amount, adding money, subtracting money. That's all we're doing. So again, restart. We defined the state of the system. We printed it to see that, okay, our code knows what the state of the system is when we started off. I defined the price of Apple, the amount of Apple that the customer wants to buy. So ideally, before even running the code, we should know that the farmer's apples should reduce by the amount of 20. And store's apples should... Oh, by the way, sorry, we are not doing customer, we're doing farmer. So the farmer is selling apples to the store. That's what we're doing. So the farmer's apples will reduce by 20 because he's giving his apples to the store. The store apples should increase by the amount of 20. The farmer's money should increase by this code, which is amount into price, right? Like, so every apple is worth $2 and we are selling 20 apples. So it'll be 40, whatever this is. And the same amount of money should be reduced from the store's state. So when I run this and I print the fruit data again, we can compare. What happened here is, wait, did I run it twice? Let me just do it once more. One sec. 1, 2, 3, and 4. Right. So what happens here is we defined store's money to be 200 and now it's 160. So that makes sense because 20 into 2 is 40. $40 got spent in order to buy 20 apples. Like it went from 50 to 70. Right? So so the amount out here ended up actually like this block of code successfully updated our state from here to here. Okay, and which is what this is supposed to be. So basically, what we have understood now is a function can do this for us. A function can take the state of the system that is, do an action, and change the state of the system. Mm-hmm. And the action generally is done by an agent. For our code, it doesn't exactly matter, but yeah, we understand what's happening. So basically, this is yeah. So now we hadn't defined this function yet. We just written this block of code. The thing is, these trades will keep on happening. The farmer will keep selling apples to the store throughout our entire thing. We don't want to keep writing this bunch of stuff. The second you realize that, hey, a bunch of code is being written again and again, you think of a function. And immediately I copy pasted the entire thing into a function. Exact same to same, change absolutely nothing. I defined farmer to, I called the function farmer to store. Mm-hmm. What I'm doing here is if we do this again, oops, I don't know what happened. Yeah. If we do this again, yeah, so this is the state of the system right now. This is what I printed out. If I call farmer to store, passing in fruit data, which is the state of the system. So we defined the function, we gave it the state of the system that it is there currently. And when I call it here, and I print the fruit data again, what I'll end up getting is 160. This should have happened. Why didn't it happen? Give me a second. Let's rerun the entire thing. Okay, so we are defining the first state. We are printing it out. We are trying this block of code. We are printing it out. We are defining this function, printing it out, using the function this time, and seeing whether the function, and the function does behave the way we want to. Apples went from 70 to 90, and money went from 160 to 120. And almost the same thing here, 50 to 90, which is $40, and apples went from 80 to 60. So exactly the same thing that we did on top, which worked. I ended up putting it into a function, and then whenever I call the function, it does the exact same thing that it was doing. Is that clear so far? Like, basically, what we did is we we realize that farmer and store, right, are two different agents which are doing a trade. The trade, all of their wallets or data or whatever is in this dictionary, which we pass to the function which represents this action, which is the trade. And it ends up actually doing what we want it to do, which is reducing the money and increasing the fruits. And that's all that our code actually needs to know about the system. It doesn't need to know what they spoke about during the day. Like nothing else is important to the code apart from the fact that apples increased and money went down after the trade was done. And we are able to actually do that. Any questions?
Yes.
No?
I'm like, yes, questions. I don't understand how this transaction now was performed, because is this still drawing
the
from
code
like?
itself?
Oh, this is drawing from there. Okay, okay. So this is the function.
This is the function call. So whenever I type this, it tries to figure out, hey, where was the function defined? It goes here and runs this block of code.
Okay, can I ask something that might be a little bit weird? But
yeah.
So we would assume that every time the price doesn't change, right? And every time they want 20 apples.
Yeah, so that's a problem with our code. And that's a perfect realization. Like we are defining the price, we're defining the amount. And that's a problem. Like, because what if the farmer wants to sell more? What if the farmer wants to price it more? We haven't been, those levers are still inside the function. And what we exactly need to do now is remove those levers outside the function so that when we call the function, we should be able to define it every time, how many apples they want to sell. And we'll move to that. And that's the next step.
Okay, cool.
Yeah. So the reason I'm going this slow is because I want to make it a point that this is how I code too. Like I don't start off with define function, blah, blah, blah. I don't know what to put into the function. I have no clue right now. What I'm just doing is I'm looking at this chart. I'm seeing that this is one kind of trade that is happening, and I'm trying to define it by saying that, okay, I know that apples should go down, apples should go up, whatever, right? So I'm trying to portray that into a block of code. Once I know that the block of code is doing what I want to, I push it into a function. And after that, when I know the function is also working, I end up now exactly doing what Stella asked to do. So it's working, but every time we don't want to sell 20 apples every time, right? We want to define all the things we want to do. So now we define a new function. And by the way, I've kept these question marks here, so I'll ask you guys to fill this up. But the point is, like, we define the same exact thing, but in a more abstracted way, in which instead of assuming that the farmer is always selling to the store, instead of assuming that the price of apple is 2 and amount is 20, I'm keeping all of that open now. I'm going to give all of that data to my function, redefine price, amount, and everything, and then do the same computation again. So instead of hard coding 20, what we are doing is leaving it up to the amount that we will, okay, I don't want to show it, but that we'll call later. Like we'll give it the state of the system. We'll say, who wants to sell, who wants to buy, what fruit are we talking about? What's the amount of the fruit we want to buy and how much price do we want to sell? Because this is all the information the function will need to actually execute the trade and update our state, right? So this is again like an open question. Anyone who wants to answer can answer. Like what I'm doing here is like the price of fruit, I'm gonna define through this whatever I pass to the code. Amount I'm gonna pass here. Doesn't matter for us right now. I could have written 20. I could have written 2. Every time we pass it, it'll be different. The question is what goes here. So fruit data is supposed to look, when we go into the fruit data, it's supposed to choose one of these 3. So something goes here, like some person or agent goes here.
I say seller and fruit in the first line.
The first line is?
Fruit data, seller.
Seller. Seller, you mean farmer? I mean seller, sorry, yeah, seller.
Seller.
My bad.
I mean
Yeah,
seller.
the seller function.
I'm serious.
Yeah.
And then it's
Yeah.
fruit. Okay, someone else does the second line.
Yeah. The reason it's fruit is because we are subtracting it from the seller, right? So this is a trade that defines what goes away from the seller. Yeah.
This is the first section is the inventory, right? And the second section is the transaction, I guess.
Yeah. So,
right.
Yeah. And is this making sense, by the way? Like, so this seller, by the way, when we call it, right, we'll call it farmer. Like, we'll pass farmer into this. So when we type it here, farmer is what will come here, which is what was there in the original code.
Yeah.
This is the hint for the next one. So when we go into the seller, like which is the farmer, what do we want to do? We want to reduce the amount of fruit in it, right? So which fruit do we want to go by? I mean, not which fruit, but
apples. Yeah? Apples.
Right. So if we did apples, right, it would work, but it would reduce the amount of apples every time. The thing is, we are keeping this open, right? So what we should do here is actually just put fruit.
Fruit. Yeah. I just realized that. Okay.
Yeah. So these are the steps we take when we are writing functions, right? We first see the code is working, then we put it into a function, then we start taking one variable out and start abstracting it away. Like instead of predefining apples, let's do fruit. Because in the future, I need not only buy apples. I could just pass fruit to this function and it'll reduce the amount of fruit in the person. Like, what goes here? Lutra, do you want to go for this?
Yes, it should be the store and fruit as well, right?
Yes, the fruit here, that's right. The store, again, we don't want to predefine it, right? Because what I'm trying to do is, instead of saying that the farmer is going to sell to store all the time.
Oh, then there should be buyer, I guess.
Yeah, exactly. Perfect. Yeah, you got this. So the seller, which will be basically this thing for us, like a farmer for us for this trade. The buyer will be store for us, which we'll pass when we call the function. Fruit and fruit. That makes sense. Here, money is predefined. What goes here again? Starter, do you want to go with this? Like, whose money will increase? Anybody, right?
Seller.
Seller's money should increase.
Yeah, perfect. And buyer. Yep. So when we define this now, if you realize this is a much, I'm going to just comment this out because we're going to use this definition. This is something I've done before, just to make sure. And let's start another. Yeah.
Sorry. Why is money predefined? Why can it not be price?
No. So money is just the because everything we'll trade through dollars for now.
Oh, that is just
right?
Okay. Yeah, got it. It's kind of the bank account. Okay, sorry, got you.
Yeah. So wait, are you still there? Yeah. Right. Okay. Yeah. So basically, the point is we are gonna define the price, and we have used it here, price of fruit. So. I could have actually, by the way, just because since we are passing price, I could have just written price here. But just for clarity, what I'm doing is when we're passing amount and price, I'm just for clarity defining that, hey, price of fruit is price and amount of fruit is amount. And we're going to use amount into price of fruit to define how much money should increase or decrease. Right? Again, so let's define a new state, almost the same thing that we started with. Let's pass that new state to our function that we defined. And now, instead of the farmer selling 20 apples for $2 every single time, what we're defining as farmer sells it to store. What does it sell apples? How many and for what price? So when I run this and I see the code again, we should see the exact same thing that happened here. 160, 200 became 160, 50 became 70. But what I can do now is I'll run this code again to restart the state to whatever system you want. I can make it $30. Sorry, $30. And if I run that again, this time it's 140. Because 30 into 2 is 60, and 60 is what? 200 minus 60 is what happens.
Roro, I'm sorry I'm interrupting so many times, but I just have too many questions. So what happens if you would be asking for too much, right? So right now, there's like 80 apples still in store. Let's say you would be asking for 100 apples, right?
Yeah, let's try this.
Yeah, just out of curiosity.
So that's a very good question. And okay, surprisingly, it was exactly the same amount. So let's do 200 and let's start from scratch. I rerun the code, so I'm restarting the state. And yeah, so money became minus 200. And that's a problem.
So it will end up becoming a deficit. Okay.
Yeah, because and also minus 100 apples, which makes no sense. The reason that's happening is because we have nowhere in the code have we written whether a trade should, like, we've never said that, hey, apples can never be negative, right? And that's where system requirements in the beginning becomes a part, right? Like, we want to define a system, but we want to make sure that there are certain laws that the system actually follows, which is that fruits should never go negative. And the code will do whatever we ask it to. It has no idea about, like what money is, what we are just calling it money. It doesn't know what money is. It doesn't know what fruits are. But it's going to do whatever we ask it to do. We'll keep on like subtracting as long as we ask it to. Oops, what am I doing? How do I shut this? Yeah. What is this though? Okay, never mind. So like we keep on. So that's why in our function, we actually should also add a conditional statement. And the conditional statement should actually say that run this code, like this part of the code, which actually updates the state, only if the person currently has that many fruits to sell, only if the after selling, and the customer actually has that much money to buy. So that should be a conditional statement, and it should go somewhere like this, where I would put it up like this. I write if, fruit data, seller, and whatever. Like, I mean, we can do this later, but the point is that I just want to say that I want to make sure that only if fruit data, if the seller's fruit, these are only if the seller has that much fruit, which is greater than or equal to the amount, then I want this code to run. That is generally how you would go about it. But for now, let's not do this. It will become too complicated for everyone. And we'll just assume that.
Yeah, but that's good to know that. Sorry.
Yeah.
It's good to know.
And it is good to know, and it is important because mistakes like this will end up creating system behavior that you don't expect. Because most of the time when you're doing like a bunch of series of actions, in the middle somewhere maybe things got negative, and actually you wanted to, once the store goes bankrupt, maybe they don't have a chance to actually buy or sell something later on, but we are not able to define that. And having those statements that say only if this and this is true, then execute this code is very important. And that's why testing comes in. Wait, where were we again? Yeah, so we redefined the fruit sale, like we abstracted away. Both of these actions now became the same exact thing, and we just define what we are buying. Since we realized that these actions are exactly the same, we were able to abstract it into a single function. And in order to execute it anytime, all I have to do is call that function, like so. I call fruit sale. I pass it the data of the state currently. I tell it who wants to sell, who wants to buy, what fruit they want to sell, how many, and for how much. Yeah. So, okay, bye, Starter. Thanks for joining in. Is everyone clear? Like, I think if we've gone through this, then we are pretty much like done. We've understood how to define states. We have understood how to change states. We have understood how to define agents within that state. And that basically is the entire, like, for the most part, that is enough to model most systems. Lutra is asking, so whenever I want to add some kind of restriction, I will use the if statement. Yeah, I think so. Yeah. I mean, so anytime you want to say that if this condition is true, only then run this, or if this condition is false, then run this, that's when the conditional statements start coming. And yeah, so once we've defined fruit sale and we've abstracted everything away, what I'm saying is like, let's not do this exercise. Maybe this is something you all can do like at home, like as a homework. But I just want to show you that the system let me just refresh this. Yeah. The system we tried to model currently was pretty simple. It was just, we have 3 stakeholders, 3 roles. Every role performs a certain action, and we found a way to define the action through a function and do it. What I want to actually do here right now is just let's just talk through how we would go about modeling this system. What the system basically is I added certain more complexities now. Once we have defined the function, we know how to do the fruit sale, right? So there are multiple farmers now. There are 2 stores that they can sell it to. There are multiple buyers that will buy from the store. Maybe I want to add the idea that fruits, like farmers grow fruits. So after every week, let's say, farmer comes back, gets some amount of fruit back into their wallets or like into their state. And I want to add a function of rotting, where I want to say that if the fruits don't get sold for 2 weeks, then the fruits start rotting. This is quite complicated. This is significantly more things are happening here compared to what we were doing. But going through, just thinking about how I would build the system out would be really beneficial. And I feel like even building these diagrams actually really helps me understand that these are the value flows or within a system, and how I can use this diagram to convert to something like this is what I do. Convert to something like this, which is for me the logic that my code is going to follow. And from this, I can just write a function. So for example, we already wrote the fruit sale function, right? Farmer decides to sell, triggers the fruit sale function, which is like a function that we defined, and it updates the values of the fresh apples, fresh bananas, store's money gets updated, farmer money gets updated, farmer's apples and farmer's bananas get updated. The point is that this is something we've already done before for the simple system. And once I think about the system like this and understand what the state is, I understand that all of these lines in some way are updating the state. Then I know that, okay, the state is a nested dictionary. This is a function that will change my state. These are new functions that we've not defined, rotting and, it was here, right? Like rotting and growing. But again, if you think about it, this function wouldn't be that hard to write, right? All I need to do is every time, we'll have to define time, by the way. It's a new thing that we are doing right now. But whatever time step we define, after every time step, some apples and some bananas add onto the state of the farm, right? That's basically just those 2 lines, like whatever, like farmer, apples, plus equals to 5 or whatever. Mm-hmm. So the point is that what I wanted to convey through all of this is that once we understood dictionaries, functions, we can actually go through the entire modules 2 and 3 we can think of about any system as long as I can create this value flow. As long as I can map the stakeholders, I can define the roles and the actions that they have in the system. I'm able to build a state as a dictionary, build the actions as functions, and I'm able to then run a simulation. The reason I go about defining it this way, and we could go into this later on maybe, but the reason I go about defining things in this format, which is what inputs my functions will take in order to give what outputs, I'm able to actually define that, hey, first things will start spoiling. Like this is something that I visualized into the system, or like thought about in the system, that let's say the store has a bunch of fruits. Every time a new week starts, some of the fresh fruits will become spoiled, like start getting spoiled. The spoiled fruits will start rotting, and like they'll have to be thrown away. Farmer will get new apples and bananas into their wallet. The farmer will decide a sale and to sell to the store, and the customer will buy the store. The reason buy the item from the store. Mm-hmm. And the reason I've defined it this first and this second is also there's a logic behind it, but because there could be a case where customer tries buying, but the store doesn't have it yet, but the farmer was planning to sell it. So maybe if we define it that, hey, first farmer sells and then customer buys, we solve that problem. And this, by the way, is called a block. So what we're doing is, now that we're adding time into our system and we want to update things through time, we need to define blocks. And these blocks will basically keep on looping again and again and again. Every time the state starts, like a new week starts, some fruits will get spoiled, some will rot, farmers will get more fruits, farmer will decide to sell, and customer will decide to buy. And this basically defines the entire system. If you look at this again, all the round things are like functions that we can define. These are just our dictionaries, like fresh apples, fresh bananas. Sale apples were just like spoiled apples before rotting. Farmers, and also, by the way, if you want to define fresh and like stale apples or whatever, the way we can do that is again just add the property within the dictionary. Like we have this defined. We can add like fresh apples and stale apples as two different things. Mm-hmm. And now successfully we've actually able to like build the data structure and add the state update function. But the point is, every time you have a conception, I want to add this, I want to add that. Now you have a methodology to think about first drawing the diagrams, then using those diagrams as representations to build the logic. This is my function. These are the things that it'll need, and these are the things it'll update. And the second you build this too, you have actually done pretty much everything you need in order to code. Or you can pass it on to someone else who would code the system for you. So yeah, that's also like this set the way I thought about all of this, like the system inputs, system state inputs, system update logic, and system states. This is something I learned from CAD, like which is a Python library, which is like once you have something like your system in this format, it does all of the things for you, which is running through the loops again and again, storing the data into a data set. I can then use all of that to plot. I can run experiments. I can add stuff like every single week, not the same amount of apples and bananas will grow. Maybe I can add some stochastic process, some kind of random process through which I can run hundreds of simulations and see every time there'll be different results. But maybe I'll know that how many times the system breaks and how many times the system doesn't, like how many times the store goes bankrupt or not. So yeah, that is the entire flow of ideas from coming up with a concept, building a diagram, building a differential model specification is what this is called. And then these blocks will be what we code. Use functions to define these, and use policies to define the decisions that the farmer, like when a farmer wants to buy or when a customer wants to buy. And these are just dictionaries. Also, just to completely overwhelm y'all, I'll show you this. Ethereum economic model. This is an entire model of Ethereum going from proof of work to proof of stake. And you can actually see the differential model specification here. And it's exactly the same that we've done. Open image, yeah. The same thing, like defining validators, defining staking, based rewards. And this thing, like this is all that you need to model all of Ethereum's switch from proof of work to proof of stake. Which validators will benefit from it? What happens if inflation happens in the system? Like all of these things are all out here.
Can you put that link in our chat?
Yeah.
Thank you.
I mean, this is way too much, of course, but and even I look at this and I'm like, okay, there's no way I can do this. But now we have step-by-step process to actually do what we were talking about. Oopsie, that's not. What are we doing? We're going to
Roro, should we put a dot on it for today?
Yeah, I think we went through a lot.
Yeah.
But I hope at least everyone's been able to understand the flow of ideas and what Python primitives we use for what kind of task that we want to do. It doesn't matter if you're able to code or not right now. As long as you're understanding how to read some of this, you're already way ahead of where you were, and you'll be able to go through module 4 pretty comfortably.
That's amazing. Thank you so much for doing
Roro,
yeah.
Thank you so much. That really was such an instructive lecture, and I really got a lot out of it. So it's more about the general way of thinking and understanding the system, and that's what I was missing. So that was really a wonderful session. Thank you so much.
Thank you. As long as as long as I was y'all understood the gist of it, then I've done my job here.
Hibiscus cultivar wanted to say something.
Oh, I just wanted to say thank you, Roro. That was spectacular. And the other thing I wanted to ask you was when you talked about how we go from design to, and differential, what's it called, differential modeling?
Yeah,
once you
specification.
Yeah, once you come up with the block chart. I mean, is that division of labor quite common, whereby you design something, you come up with the blocks, and then coders started to do the sort of heavy lifting, so to speak?
So the thing is, from what I understand, this is like block science. I guess maybe the name also comes from that. Like block science, this was their internal practice. This is how they did it, and CAD came out as an open source project from their internal workflows, which involved the entire thinking of the system as a state, using that state to update states from time to time. Like it's very common, I would say, in non-linear dynamic systems when you're trying to model something that is, if it's a linear system, you know that when I increase apples, the price will increase. It's where I don't need any kind of crazy model to do that. But when there are many stakeholders, everyone are complicatedly connected. They all have this, the system has these properties where if you change a little of parameter somewhere and you don't know the kind of effect it'll have, because everyone will affect and everyone's behaviors will get affected, maybe. Like, for example, increasing the interest rate to control inflation in economics. That's something that, that's a very complicated, complex system. Complex systems, one of the ways to tame it is something like this, where you build out the model, you build out all the actions and roles that people take in that model. And then you just, if you have conceptualized time well enough, which is that, then you can put them in blocks. Like these are the set of things that happen in 1 week. And you can keep on like running it again and again and see how it works. Maybe I could do one thing and just very quickly show you all where this goes. Like, so for example, wait, let me share my screen. If it's obviously like if it's too exhausting, we cannot do this. But I'll just like
maybe let's do this next week. I was about to say.
I just wanted to, since I already like told everyone this thing.
Oh, that's pretty.
But yeah, the Ethereum model specification. So this is all of it, which is crazy. Like the model is in this folder. All of like state update blocks are defined here. Variables are defined here.
They have all their own little section for these things?
Yeah, every single thing is a separate Python file. So policy functions are here. So like, wait, so I'll show you state update blocks, right?
Yeah.
Yeah, the variables that will change and the policies will change. I mean, CatCat has its own structure. Just ignore all of this. The point is, let's look at the experiments, like what actually comes out of it, right, at the end of it. They actually did model validation. So profit yields across validator environments. Validators are the proof of stake validators. And they ran all of this and they found out that there are validators with different kind of DIY cloud systems, DIY hardware systems. They've defined all of these and whose profits will increase or decrease over time based on changes. Same with her. Wait, I don't exactly know what that one was, but yeah, they've like basically been able to see that like, you know, how much validators cost will increase based on different decisions that the system like that different parameters that we change. Like when inflation increases, for example, of each state, network inflation rate, and how the net yields change for different validators. All of this, like the point is, once you define the system, then you can define people's behaviors and then use that to actually run models like this. And this was done by the Ethereum, was it Robust Incentive Group or something? And they've like done a brilliant job. I mean, the way they've made this file, it's just so big. To me, I've never seen a code file this large.
Dumb question. Why is it Python based rather than Solidity? I thought it was Solidity based.
So Python is really effective tool to do data science in. So whenever you have because there are many libraries like Pandas, NumPy, and stuff like that, which make it much easier to do calculations in Python. Solidity is still a new language, and it's much more tedious. Like Python is a much more high level language, which means it's much, easier to define what you want to do in Python. If you look at the code, like the fact that you could even read it till here was probably because you wouldn't have gotten this far with Solidity. It's just
got it. So it's a good illustration tool before you go into the deep end for actual coding.
Yeah. So Python becomes so what we're doing here is using Python to validate the ideas that we have. So for example, if I have ideas like, hey, should I increase the inflation rate of this system? Should I, how much should I mint? How much should I burn? Or whatever random ideas that you have, those parameters, you can test through Python first, because it's much easier to code in Python. You can do these experiments before your actual Solidity coding starts. Because if you deploy your system already, that's a problem. Like if you haven't tested and validated things before. But there are other things that there's, I think, Token Spice, which combines Python and Solidity, and you can actually validate systems and go through, it goes through Solidity code and validate system. But I've never used that software or like that library. Python is CAD especially is purely like Python based, and it's very similar to machinations. Just I feel like Python is just like the data science suite that it comes with. I can once I define the system, I can actually build reinforcement learning agents, like agents that learn from the mistakes they've made and start making different choices. So in this, even in this farm store model, you could have farmers that have two different stores. They start with selling in one store, then try selling in the other store, realize, oh, this store is actually much more cheaper, and actually make those decisions. Like, I mean, that's a very simple one. You can do it without machine learning, but I could potentially build much more complicated agents who learn from their mistakes and actually, because that's how real like humans function, right? Like they make decisions based on how the system is currently and what they think that their current best utility will be. What actions should they take to increase their utility? Like arbitragers will find the best opportunity and they'll try out different things and find the best one, learn from their mistakes and things like that. So Python can actually build agents like that. It would, I don't know if Solidity is something you would want to use for data science, right? Like that's just, even though you could do that, like it is a, what do you say? It's a Turing complete language. So you could do that. It's just too tedious and unnecessary. Yeah. Python is equal to machinations in simplicity. That's a good way to visualize it. Yeah. Like, I mean, machinations is again like a much better UI, much better way to actually like visualize your system. But there are certain things that I would want to do which are very difficult for me to do in machinations. For example, I want to build stochastic processes, like in the sense that there are different times of the week, the farmer will grow different kind of crops. That's something you can do with machinations, but do that, but run 100 simulations and take the average of the, which is called a Monte Carlo run. Like you take a stochastic input, run like 100 simulations and see what the mean or the average metric is for you to find out like how many times the system breaks. All of those things I can't do in machinations easily. Another thing I can do here is run like parameter sweeps. So like, for example, if I'm making a decision about what should I price my item, I could actually, I could just define an entire list of prices for my item, run simulations for every single piece, and find out which price actually performs the best for me. Again, not very useful in this system, but if you're imagining something like a AMM, and we need to test out what constant product should we work with, or what, what kind of bonding curve should we set up. You would want to like run through a couple of parameters and be like, okay, this one's the best one. That Python would allow, but probably machinations you'll have to replicate the same structure many times to do it. And so yeah, like maybe like, but for us, like again, like if you don't know how to code, building it out on machinations makes the most sense. But again, going through the process that I defined would really help you, like, which is first visualize it on paper or like, a chart, understand what your state update logic is overall, like through the differential specification diagram, and then convert it to something you would build on machinations. Because then you have a very clear workflow. You're not just going like, you're not just winging it. You might miss something that way. Yeah. Kojak is typing something. I have to leave. Okay. Thank you. And maybe we should like close the session. If we want to discuss projects, we can take it here. But decide, that's on you, Stella. Like,
No, I think we're like, I really want to do the projects, but I think we're right now so deep in with the actual learning for Module 4, and I realized a lot of people are tackling right now Module 4. So I think it's quite the right time. For next week, I think maybe we can really focus on the rest of Module 3. So we get that done with, right, before then actually starting Module 4 officially, and kind of encountering all the things that we don't know about Python yet, and that you can take it away in a special session number 3 about Python, if that makes sense.
I think we covered pretty much everything now. And other stuff, everyone can just go through like W3 schools or something, so it shouldn't be an issue now.
I think so too.
But I think we can do async, you should always ask doubts, like anyone who has doubts, I'm always there to answer. And if you all want to even do private sessions, like at least just to understand where you're getting stuck, I'm open to help.
Thank you, Rohan.
Thank you so much. That was amazing.
Guys,
It was, definitely.
Yeah, thanks lots.
All right. Thanks for coming, and
see everyone next week.
See you next week. Bye.
Bye. See you next week.